Hello everybody. Today, more than 80% of human global calorie supplies is based on crops. And to keep us fat, the United Nations predicts that within the next 30 years, we have to ramp up global food supply and production by more than 50%, despite water shortage, without new land, and under changing climatic conditions. My name is Max. I'm the CEO and co-founder of ConstellR, which is a joint spin-off of two of Europe's largest research organizations, Fraunhofer and the German Aerospace Center. And with ConstellR, we are going to help safeguard humankind's food security by answering the market need for high-resolution temperature monitoring services. Because we agree with the United Nations, agriculture must become more efficient. And to do so, we need systems to monitor our crops' health, daily, globally, and on the single field level. With ConstellR, we're going to provide exactly such a system from space. Since already today, there are a lot of analytics companies, so those companies we're eventually going to sell our data to, which are using a variety of data set to create information products, for example, in agriculture. This then enables their customers to, for example, better predict or increase crop yield. But the market is facing several challenges. First of all, not all data is well accessible. And more severely, we have dramatic gaps in our monitoring capability. Because while current satellite systems have amazing imaging capabilities in the visual and radar spectra, neither of those spectra is well suited to perform crop health monitoring. To do so, we need to take the plant's temperature in the thermal infrared, but here we simply don't have enough coverage. So current Earth observation systems are not fit for purpose, and that is putting a massive constraint on the market. With ConstellR's patent-pending architecture, we're now able to miniaturize the necessary technology and enable CubeSats to do high-precision thermal monitoring. This means that now, for the fraction of the cost of one large satellite mission, we can send dozens and dozens of smaller satellites into orbit, which are then continuously delivering the data we so severely need. You may argue, however, that there are different other ways to obtain this data, and you're right. We can stick sensors in our fields or fly drones across them. But the only globally applicable solution to this global challenge is coming from space. And there are notably a couple of other organizations which are currently also trying to put their capacity into space. What makes us confident to win out in the end is the fact that all of them have to compromise on either spatial resolution, on global coverage, or on large system accuracy. And this will make us the only provider with a combination of all these requirements. So high resolution, global daily coverage, and large system accuracy. But compared to large systems, we are not only going to be 30 times cheaper, but we're going to be scalable. And the scalability is key, because the market we are entering is strongly driven by population growth, by climate change and agriculture regulations. Following reports of Euroconsult and others, we estimate a total addressable market size by 2030 of around $11 billion. While agriculture is our initial market and the analytics companies therein, our initial customers, we already today get requests from companies outside of this market, for example, in infrastructure monitoring. So they want to have our data too. We therefore believe that by the end of the decade, we have an annual revenue potential of $100 million. And we're confident to achieve this because our team is not only covering the technical side of things, like space engineering, but we've also picked up in-sector market knowledge during our times at companies such as Airbus and Munich Re. In fact, we are combining the research strength and innovation strength of two large research organizations with our own startup drive and industrial manufacturing quality of our partners such as OHB System AG. To this date, we have secured more than €2 million of public funding and will launch our in-orbit demonstrator already next year. We're then going to stepwise increase the coverage driven by the market demand. So, if you want to save fresh water, speak to us. If you want to grow your crops better, speak to us. If you would like to have better crop yield prediction, speak to us. And if you need high-resolution thermal infrared data for any application in infrastructure monitoring, wildfire detection, irrigation management, you name it, we're happy to talk to you too. Thank you.
Join me here.
We'll have a quick Q&A. My handheld microphone doesn't work, but nevertheless, I would like to give the audience the opportunity, as well as the jury, of course, to interact a bit. This is the area where direct democracy is possible and smart. Okay. Any questions? Yes.
Hello. What would be the size of this constellation in...
A bit louder, please.
Size of the constellation in number of satellites?
Yes.
Expected.
So, depending what we aim for in the end, so as I said, it's scalable. If we would like to have daily global coverage with 50 meter, or a little bit below 50 meter resolution and 1 Kelvin temperature precision, we need something like 30 to 35 satellites. Depending a little bit on how the constellation actually works, how many launches we will have, but that's about the rough number.
Any other questions?
Well, this was a really good pitch. Sometimes no questions are a good sign in this case, or a few questions.
Or speaking too fast, maybe.
No, you did really well. Thank you so much. Thank you.